Good day. This is the presentation of the group 6 for the Finite Element Methods group project. The application chosen for the analysis is the analysis of a leaf spring suspension. The group 6 consists of 3 persons, which is me, Hafizuddin Bin Juhari, Muhammad Afiq, Abdul, and Tanis anak lelaki si Annanthan. Okay, so in lots of heavy-duty trucks, leaf spring is used due to its capability to perform greatly with heavy loads. Leaf spring is made of several number of flexible curved plates or leaves that are intended to straighten when vehicle is subjected to load. This comes to the project statement, which is due to the reason that the component is subjected to a very high load. It is important for a thorough analysis to be done in order to make sure the leaf spring is capable of withstanding the load for a very long time and operating under the safety limit set by the manufacturers. The objective of the project is to use finite element analysis to analyze the stress distribution of a leaf spring and find the maximum stress, displacement, and safety factor within the component. The 2014 Toyota Hilux 3.0 D4D is used as the model specification throughout this analysis. The curb weight of the Toyota Hilux is 2,025 kg, while the maximum allowed load mass is 705 kg. Therefore, the maximum vehicle mass is to be assumed is 2,730 kg. For the load case number 1, I will pass the stage to Mr. Tanis.
Thank you very much, Hafizuddin. So I will continue with load case 1 vehicle undergoing braking. During braking, the vehicle with mass being shifted forward. This makes the rear vehicle getting lighter, while front part getting heavier. This analysis involving quarter car model, where it's focusing on only one rear leaf spring. According to resources, 2016 Toyota 2.0 D4D able to stop from 80 km/h to 0 in 26.1 meter, which is equivalent to 1.175 seconds. So next, the braking force of the vehicle is determined by using Newton's second law of motion, which produce value of 9,574.45 Newton. On the other hand, the vertical load is also being applied to the vehicle, which contribute to 2,483.1563 Newton. This analysis is conducted by using various element size ranging from 4 to 20 mm with 2 mm interval. Next. From the simulation performed via SolidWorks, these are the results obtained. For your information, the maximum stress and displacement occur when mesh element size is 4 mm, which is the smallest, thus provide us the most accurate value. For your information also, the deformation size of 75 is used in order to show deflection of the leaf spring. From the analysis, we are able to obtain maximum stress of 0.1798 gigapascal, which is in red color in the figure next to it, while the maximum displacement obtained is 0.633 millimeter, also viewed as in the red section in the figure. Thus, it contributes for offset factor of safety of 1.1, which is barely safe because the model used might not be the same as the one used in the vehicle. Thank you.
Okay, next we will go through to the load cases 2, which is when the vehicle under the maximum vertical load. Okay, next. So basically, during this pandemic, most of the people start to work from home. So usually vehicle will not moving for a long period of time. Then probably every vehicle will experience additional load. It is because people that working as a contractor, for example, as a contractor or mechanic, usually leave their heavy stuff or their belongings in the vehicle. Thus, the car will having more load in static condition. Therefore, this analysis involving the quarter car model that focusing on one rear leaf spring. Next, according to resources, the curb weight or the net weight of the vehicle is 2025 kilogram, and the load capacity, which is the maximum load that can be in the vehicle, is 705 kilogram. Then the total maximum load of the vehicle is 2,733 kilogram. Distribution weight for rear tires is the 40%. Then the remaining 60% is at the front of the vehicle. So each tire at the rear consists of 20% of the weight. Thus, weight distributed at each tire at the rear is 1,092 kilogram. So the vertical load applied to the leaf spring at the rear is 5,356.26 Newton. Analysis also conducted using 4 to 20 mm element size with 2 mm of interval. Next. This is the result and the finding from the simulation from using the SolidWorks. So the maximum stress and displacement occur when mesh element size at 8 mm. So basically, when we use the different element size, we can identify the maximum stress occur at which element size. So next, the deformation of the spring, we can see at the picture, they're shaped like W shape due to the upward vertical force. Then we can see also the critical point is at the middle of the leaf spring. Thus, the maximum stress occur at 8 mm of element size is 80.46 megapascal. So it happened at the middle of the leaf spring. Then the maximum displacement is 0.1378 millimeter, also occur at the middle of leaf spring. Then the safety factor of this leaf spring due to the maximum load is 2.74, which is safe.
So, as a conclusion, the finite element analysis done for the leaf spring bring to the result that shows the component safe when subjected to the maximum vertical load with a safety of 2.74 and safe when subjected to a full braking with maximum vertical load with the safety factor of 1.1. In the case of full braking with maximum vertical load, the spring is merely considered safe as the factor of safety is only with a difference of 0.1 before it is considered to fail. This condition is not desirable as in the real condition there would be extra factors that may contribute to higher stress within the component. Therefore, it is crucial for some improvement to be done towards the design of the leaf spring. By adding the number of the leaves or blades in the leaf spring, it can help decreasing the maximum stress within the component. Therefore, the factor of safety when the vehicle is under full braking with maximum load can be increased, thus increasing the capabilities of the components to withstand the load. This uh, this is the end of the presentation. So thank you.